All right, here's our second video on calculus, part two of limits. We talked about limits last video, talked about what they were and so forth. So today we'll talk about solving them by factoring and also by just plugging in. And there's other ways of doing limits, which we'll do in other videos when they get more complicated. So let's go. Right, let's get our pen ready over here and a clean page. All right, so in the last video, we had a limit. Put the limit here. We had a limit as x was approaching 1. There's a sign as it approaches 1. And we had x squared minus 1 over x minus 1. Now you notice when we have a problem like this, is if x equals 1, this will become undefined, right? Because 1 squared is 1, so it'll be 1 minus 1 over 1 minus 1. And you get 0 over 0, which is undefined. We talked about that in the last video. Remember, you can't have a 0 in the denominator. And we're going to talk about this problem in a minute. But first, we're going to look about what if we can just plug in numbers. So let's look at 1. Change the color. What if I said the limit as x approaches, let's say 10. And don't worry about that little dot there. Shouldn't be there. Just hanging out today. And we had the x divided by 5. So if we just plug in 10, we'll get an answer. The answer will be 5, right? So if we plug in x for 10, because there's the 10, got rid of that dot, right? So it's 10 over divided by 5, and we know the answer will be 2. That's easy, right? Just plug it in. So this is just plug it in. Plug it in. That's your first step. When you ever see a limit problem, the first step is just to plug it in, see if it works. If you looked at the first problem we did, if we plugged it in, we will get something that's undefined. So we can't use 1. We wanted to use something close to 1. All right, let's keep going. Why don't we keep that up there if you want to look at it? Change the color again. Use purple. And what if we had a question that says, what's the limit as x, all right, remember that symbol, approaches 5. So we're approaching the number 5. And let's say we had 10 plus 4x. First step, plug it in. Just plug the x in. So it would be 10 plus 4 times 5 gives us a number, right? What'd you get? If you plug it in, you'll get 30. So the answer will be 30. So there it is, just plugging it in. Let's clear this out. We'll do another one. Maybe we'll use green now. What's this answer? See if you can get this answer. See if you can read it too. What are we getting here? Just plug it in, right? Just plug it in. It says the limit as x approaches 5. Just plug it in, and what's the answer? 5/6. There's the answer. Just plugging it in. So now let's go back to the original problem. So this was just plugging it in. Just plug it in. That's your first step. So we had the limit as x approaches 1 for x squared minus 1 over x minus 1. We can't just plug this in, because if we plugged in, first of all, we're missing a number here, as x approaches 1. Forgot to put it in. We plug it in, it'll become undefined. So we want something close to 1. Right? And so what we can say, what's close to 1? Well, if you did 0.99 squared minus 1 over 0.99 minus 1, you can see that it's a 1.99. It's closing in on 2. In fact, if we kept increasing the 99, like 0.999 and so forth, it'll get closer and closer to 2. So we can just estimate that it will be 2. But if we want to see that it is 2, we're going to do factoring instead of doing what I just did there. And again, we did this in the last video, but factoring we're doing now. So we'll factor x squared minus 1. And you should know the difference of 2 squares. That you should know already. So if we did the difference of 2 squares from x squared minus 1, we're going to get x minus 1, x plus 1 over x minus 1. And we can just cancel out the x minus 1, and we're left with just x plus 1. So now we can plug in the 1, and we'll get our answer is 2. just like we said we thought we would get as we get closer and closer to 1. Now, just in case you don't know the difference of two squares, let me just show you quickly, but you should know that, and I have videos on that also. So let's clear that out. Go back if you need to. So for example, if we had x squared minus 4, let's do that over. X squared minus 4. These are two squares, right? Because we know that the square root of x squared is x, right? Because x times x is x squared. And the square root of 4 is 2, because 2 times 2 is 4. So we know that. So these are perfect squares. So we're going to get the difference is 2 squares. And when you do that, you're going to say, what you're going to put down is we have our x minus 2, and we're going to go x plus 2. And that's how you do it for the difference of two squares. You always have a minus and a plus for the difference of two squares. So let me give you one question here. We'll erase that, clear that out, try to clear it out. And let's have a problem here. What if I gave you, what's the limit as x approaches 3 for x squared minus 9 over x minus 3? Now, what happens if you plug in 3? Because remember, your first step is to try to just plug in 3. If you plugged in 3, you would get a 0 in the denominator, and that's undefined. You can't do that. So we're going to factor. So pause the tape, try to factor, see what you get. All right. So we have a difference of two squares over here, right? So this should be x minus 3, x plus 3. That's the difference of two squares over there. And x minus 3. And we cancel out the x minus 3, and we're left with is x plus 3. We plug in, and we get our answer of 6. So that's what you should have had. Let's do one more. Again, go back if you need to. We'll clear that out. And maybe we'll just change the color. So what if I gave you this? What's the limit as x approaches, let's say, 6? And we had x squared minus x minus 30 over x minus 6. See if you can get an answer for that. And again, you should know how to factor trinomials. So what'd you get? So if we factor the trinomial over here, we know that, we'll get x minus 6, x plus 5. So go back factoring trinomials if you don't understand how we did that. And of course, we can cross that out. We're left with x plus 5. Just plug in the 6 now, and the answer would be 11. So next up, we have to talk about what if we use infinity as x approaches infinity, and then we also have to talk about the conjugate. So we'll talk about that next video.